Hello, everyone. My name is Zane Zarger.
And I'm Austin Chen, and we're from Explore Post 1010 Botball.
This is our team breakdown. We have 7 boys and 1 girl, 1 freshman, 2 sophomores, 2 juniors, 3 seniors. If you look at the pie chart of our schools, we have members from a few different schools, including 1 homeschool student.
These are our meeting times. We meet at the Rockville Science Center. The address is right there. We are a non-school-based team. We meet on Mondays and Wednesdays, 6 p.m. to 9 p.m., and on Saturdays, 10 a.m. to 2 p.m.
Our organization is that we're split into a team captain, builders, and coders. The team captain delegates work and strategizes, while builders are assigned by the team captain to build and maintain the robots, and coders are assigned by the team captain to a specific robot, and they focus on designing and fixing the robot's code. If you look at the pie chart of our organization, we're about 25% coders, 60% builders, and just the 1 team captain.
When handling conflict in the team, we often have a vote, with the team captain being the second vote if there's a tie. For example, we had initially had planned to get blue palms on the board, but that turned out to be a little bit too difficult for us. So as a team, we voted to switch to a new strategy of getting Botguy.
We had some team goals where some team members wanted to learn how to quickly and effectively write successful programs, and some team members wanted to be able to develop better designs and effectively implement them. And we as a collective wanted to cultivate the ability to work as a team.
To accomplish these goals, we often paired experienced members with those who are new or had less experience. For example, we had switched over from coding in C to Python. So those who had more experience with Python were paired with those who had little or no experience with Python. New members who wanted to build were paired with experienced builders. And we also had many group discussions to decide how we'll be moving forward.
We had a 4-step strategy to make our robots. First step was the concept of the robot, where we would decide what task it would complete, and then we'd build a claw and test it manually and discuss and decide on the base design. Second step was building a prototype of the robot, where we'd attach a claw onto the base of the robot and write some basic code to test the movement and claw movement. The third step was refining that robot, where we would add top hats and other sensors as needed, as well as test as needed. All this to ensure that the robot wouldn't interfere with anything else. And the fourth and final step was testing, where we just retouch and optimize code, and we'd ensure consistency with at least 10 successful tests.
There are a few risks in the strategy, but the biggest one was we needed to sacrifice stability in order to make a claw long enough to get Botguy. Several of our claws before were ineffective due to weak Lego pieces and joints. So it was possible that the claw would break off or just not complete its task successfully. We mitigated this risk by adding extra Lego pieces and used metal standoffs and other screws to make this claw more stable and stronger. This stronger design does not break off anymore when dragging the mineral transport and Botguy, and currently works very well.
One of our solutions to a design issue was initially when we were building the robot, we had an issue with the elevation of the top hat sensors since they were too close to the board to be effectively used. This issue was quickly fixed by just adding another Lego piece for elevation on the front of the bot where the ball bearing was mounted.
This is our get blue palm bot.
So the original get blue palm bot, the initial strategy was it actually didn't involve Botguy. The robot would just go forward until it hit the black line to grab the mineral transport and then attempt to drag the water ponds from the platform into the mineral transport and deliver it to the ore storage. And the original design was that it would have a claw on top and bottom to sweep the water ponds from the bridge into the container, and it would be mostly made of Legos and use top hat sensors to line follow and detect black lines. The original pseudocode was just it would go across the board until it hit the black line. It would turn away and back in to get the mineral transport, and then line follow until it reached the blue palms, and then grab the palm and line follow to the ore storage.
This is our new get Botguy bot.
So our final design, its base was a metal chassis using metal standoffs to stabilize and increase the reach of the claw. And some effectors were a singular hook-like claw that was designed to hook the mineral transport, and the arm of the claw also reaches long enough to hook onto Botguy. Some sensors we used were 2 top hats at the front and a light sensor so that it could start, and then a button sensor to detect collisions.
You can see images of our design here. You can see the claw we mentioned earlier. There's a front button and 2 top hats and metal standoffs to extend the servo to get the claw's reach further than it was before.
So these are some of our test runs of the Botguy bot. where we had 1 run where it got 50 points, 7 runs where it got 110 points, and 1 run where it got 260 points, which is the max amount of points that it can get, for an average of about 108 points.
This is our program flowchart. You can see it starts, it will go forward. If it sees black, it will stop, then perform the code that will grab the middle transport to lower the platform, then follow the black line on the platform to get on the ramp. Then if the button sensor is triggered, it will turn left and follow the line until it reaches Buckeye, and then perform the code that will knock Buckeye off to our side.
So this is a snippet of code from our program. It's a Linefall function where it takes in value time, and the end time is equal to the current time plus the time that is passed in as a function value. So while the current time is less than the end time, it'll check to see if the right top hat is on black, and if it is, it'll increase the power of the right motor and decrease the power of the left motor, effectively making it move slightly to the left. But if the right top hat's on white, then it'll do the opposite, where the left motor will have more power than the right motor, which will effectively make it turn to the right slightly. And that just all has the effect of making it line fall on the black line.
Our community is large and also uptight at the same time. We have an Instagram account where we post test runs and videos of our robot. We also have people who visit the Science Center often to attend classes or just look around, and they may inquire about our team and our robots. We also volunteer at local middle schools to help with their robotics club or robotics competitions. And we also volunteer during events that the Rockville Science Center may hold.
Thank you for your time.
This is all from us, Explorer Post 1010. Thank you for watching our presentation.